Earth's first mission to a binary asteroid for planetary defense. This has to be done, as we know, because the year 2135, which is about roughly 100 years from now, the Earth is supposed to be getting very close to, or that is an asteroid, asteroid Bennu, it's on top of a protoplanet, is supposed to be coming very close to Earth and even possibly having Earth impact. So they've got to do something to try and have some kind of technology, some kind of means to protect the Earth from Earth collisions that would mean an extinction level event. So, Earth's first mission to a binary asteroid for planetary defense. This is by the European Space Agency, as we can see here. Laser used to measure size, shape, and mass of the Moon. For example, HERA measures the Moon's shape, space, and mass. Planning for humankind's first mission to a binary asteroid system has entered its next-gen engineering phase. ESA's proposed HERA mission would also be Europe's contribution to an ambitious planetary defense experiment. Named for the Greek goddess of marriage, HERA, would fly to the Didymos pair of, Didymos meaning twins in Greek, Didymos pair of near-Earth asteroids. The 780-meter diameter mountain-sized main body is orbited by a 160-meter moon, informally called the Moon, about the same size as the Great Pyramid of Giza. Such a binary asteroid system is the perfect test bed for a planetary defense experiment to be, but is also an entirely new environment for asteroid investigations. Although binaries make up 15% of all known asteroids, they have never been explored before, and we anticipate many surprises, explains HERA manager Ian Carnelli. The extremely low gravity of environment also presents new challenges to the guidance and navigation systems. Fortunately, we can count on the unique experience of ESA's Rosetta operations team, which is incredible asset for the HERA mission. The smaller Didymoon is HERA's main focus. The spacecraft would perform high-resolution visual, laser, and radio science mapping of the Moon, which will be the smallest asteroid visited so far, to build detailed maps of its surface and interior structure. By the time HERA reaches Didymos in 2026, Didymoon will have achieved historic significance, the first object in the solar system to have its orbit shifted by human effort in a measurable way. So that's what they're trying. They're trying to use these as an example of moving asteroids wherever they want them to be moved. So this is a type of a rehearsal, let's put it that way. What they have to do, what kind of technology they have right now that can be used, if it's going to be successful or not. So it's a dry run, and they'll have to improve whatever doesn't work. A NASA mission called the Double Asteroid Redirection Test, or DART, is due to collide with it in October of 2022. The impact will lead to a change in the duration of Didymoon's orbit around the main body. Ground observations all around the world will view the collision, but from a minimum distance of 11 million kilometers away. Quote, essentially, information will be missing following the DART impact, which is where HERA comes in, adds Ian, and he explains HERA's close-up survey will give us the mass of Didymoon, the shape of the crater, as well as the physical and dynamical properties of Didymoon. And here we see that HERA uses infrared to scan the impact crater. This key data gathered by HERA will turn a grand but one-off experience into a well-understood planetary defense technique, one that could in principle be repeated if we ever need to stop an incoming asteroid. The traditional method of estimating the mass of the planetary body is to measure its gravitational pull on a spacecraft. that is, not workable within the Didymos system. Didymoon's gravitational field would be swamped by that of its larger partner. Instead, HERA imagery will be used to track key landmarks, let's start playing this, on the surface of the bigger body, Didymane, such as boulders or craters. By measuring the wobble Didymoon causes its planet relative to the common center of gravity of the overall two-body system, its mass could be determined by the accuracy of over 90%. HERA will also measure the crater left by DART to a resolution of 10 centimeters. That's pretty good. 10 centimeters is about the size of our small pinky finger. Accomplished through a series of daring flybys, giving insight into the surface characteristics and internal composition of the asteroid. HERA benefits from more than 5 years of work put into ESA's former asteroid impact mission, comments Ian, and he says, its main instrument is a replica of an asteroid imager already flying in space, the framing camera used by NASA's Dawn mission as it surveys Ceres, which is provided by the German Aerospace Center DLR. It would also carry a laser radar, LiDAR, for surface ranging, as well as a hyperspectral imager to characterize surface properties. In addition, HERA will deploy Europe's first deep space CubeSats to gather additional science as well as test advanced multi-spacecraft intersatellite links. NASA's DART mission, meanwhile, has passed its preliminary design review and is about to enter its Phase C detailed design stage.